Welcome to Brain Vision.
Hi everyone. What we have is a frigid tank of volume 0.06 meters cubed of R134A at initial pressure of 0.8 megapascals and 100% quality as indicated here. We have a supply line at 1.2 megapascals and 36 degrees C to which a valve is opened and that tank actually starts to fill up, and that valve is closed when the tank contains entirely saturated liquid at 1.2 megapascals. So what we're asked to find is the mass of refrigerant that enters and the total heat transfer. So what we're going to do is just write down our quantities and assign variables and values. So the initial volume we know is 0.06 meters cubed. We know the initial pressure is 0.8 megapascals, and the initial quality is 1.0. So that's X1 will be 1.0. The supply line pressure, which we're going to denote as PI, is 1.2 megapascals. Supply line temperature is 36 degrees Celsius. The final pressure we experience in the tank when the valve closes is 1.2 MPa. MPa right there. And the final refrigerant quality is going to be equal to 0, since we know that the valve is closing when it's entirely saturated liquid. So we're just using the definition of quality. We're also going to assume that it's a uniform process, there's no work, and kinetic energy and potential energy are going to be neglected. So what we're going to do first is solve for the specific volume. We know from the refrigerant table, A-11, that at P1 equal to 0.8 MPa and a quality equal to 1.0, our specific volume at 1 will be equal to 0.2565 cubic meter per kilogram. Similarly, using those same quantities, we're going to solve for the internal energy, and we see that internal energy U1 will be equal to 246.82 kilojoules per kilogram. Now what we're going to do is solve for our specific volume at 2. We're going to use that P2 is equal to 1.2 MPa and that X2 equal to 0, and refer in that same table. And we'll see that our specific volume at 2 is equal to 0.000895 cubic meters per kilogram. Similarly, our specific energy at 2 is going to be equal to 116.72 kilojoules per kilogram. And then what we're going to do is solve for our specific enthalpy of the refrigerant that's entering the rigid tank. And using the quantities of our supply line of PI equal to 1.2 MPa and the entering temperature of 36 degrees C, we'll see that the enthalpy of the refrigerant entering is 102.34 kilojoules per kilogram. Now what we're going to do is actually solve for the initial mass of the refrigerant in the tank, and just by using the specific volume that we solve for, we can say that M1 is equal to the total volume over the specific volume. And plugging in for these quantities of V and specific volume, we see that the initial mass is 2.34 kilograms. And similarly, we can also solve for the final volume, and that's just going to be that same total volume over the specific volume V2, which is equal to 67.16 kilograms. So we can this is easy to solve and say that we can solve for the mass that enters as M in is equal to M2 minus M1. And just by a simple subtraction, we see that the total mass that entered was 64.82 kilograms. And that is one part of our answer. We're also asked to solve for the total heat transfer. What we can do is just set up a simple heat energy balance. And we know that the energy coming in minus the energy leaving is equal to the total change in energy of the system. Now we just defined our system as the tank. So if we were to just go ahead and plug in for the energy in, energy out, we know that the energy coming in is going to be due to the heat transfer coming in and the mass that's coming in as well. So that's going to be plus mi hi. Now there's nothing leaving because this is a rigid tank that doesn't have any other valve where things could escape. So this is just going to be equal to our change in energy of the system, which is m1u1 minus m2u2. M2u2 minus m1u1. So we can solve for Qn and say Qn equals m2u2 minus m1u1 minus mi hi. Now we actually have all of these variables. We have values for all these variables. We know m2 and m1 because we solved for that using the definition of specific volume. We know u2 and u1 because we looked those up in the table. Mi we solved for, and hi we also looked up in the table. So what this gives us is a total heat transfer of 627.7 kilojoules. And that is our final answer.